The following video will help you work through single replacement reactions. In a single replacement reaction, the reactants for it are going to be a single element and a compound. And then the products are going to be a new element and a new compound. The general equation for a single replacement reaction is A plus BC forms AC plus B. Now, solving a equation here, like a synthesis or decomposition for balancing equations, is exactly the same for single replacement. In the following example, I have aluminum plus lithium bromide reacting to form aluminum bromide and lithium. Just like before, I'm going to start by making my T-chart, separating my reactants from my products. I'm going to copy down my reactants, aluminum, and I'm going to copy down that also onto my product side. I'm also going to copy down a lithium and a single bromide. The one difference now between doing a synthesis or a decomposition reaction and doing a single replacement here is I want to pay attention to how I'm organizing these things so that I can keep track of it. So on the product side, I'm going to put that bromine next to my aluminum, and then I'm going to put the lithium underneath the lithium. Now I can easily see that I need 2 more bromines to complete my AlBr3. In order to get that, though, I have to go back to the reactant side, and I have to add not only the 2 bromines, but I also have to add lithium because it comes as a compound. So I'm going to add a second lithium bromide, and that's going to add a bromine onto the product side and another lithium. And then I'm going to add a third lithium bromide. After doing this, what ends up happening is I still have 1 aluminum on my reactant side. I have 3 lithium bromides. I have formed a single AlBr3, and then I have 3 lithiums on the product side. So updating my equation, I'm not going to do anything to the aluminum. I'm going to put a 3 out front of LiBr3, LiBr. I'm not going to add anything in front of the AlBr3 because I only formed 1 of them. And then I'm going to put a 3 in front of lithium. So just like before, we're going to make our T-chart, write down our reactants, copy them onto the product side, add additional reactants as needed to complete the products that are listed above, and then write the coefficients out front. A second example problem of this is magnesium plus hydrochloric acid forms MgCl2, or magnesium chloride, and hydrogen gas. So I make my T-chart. I copy down my reactants. I notice that I need a second chlorine on that magnesium chloride, and I need a second hydrogen to go with that H2. So I'm going to come back to my reactant side, and I'm going to add another HCl because it's listed as a compound. And I'm going to put the Cl underneath my magnesium chloride, and I'm going to put the hydrogen over here. So we have now formed a single magnesium chloride and a single hydrogen molecule. When I update my equation, I'm going to put a 2 out front of the HCl, and that is going to be it for this problem. What your assignment is for the remainder of the class here is that I've given you a set of single replacement problems to work through, also with some synthesis and decomposition mixed in. If you have questions, I'm happy to answer them. I'm going to be working with the other group here to go back over the basics of balancing equations, and I hope this helps. Thank you.